Hello everyone, Dr. Chen here. So we are discussing Newton's second law in this video and we will do a few examples. So let's see what is Newton's second law. So Newton defined his second law in the principle like this. The change of momentum of a body is proportional to the impulse impressed on the body and happens along the straight line on which that impulse is impressed. Now let's try to understand it. So first of all, Newton defined a new quantity called quantity of motion. And that quantity of motion has evolved to a new name which called momentum by modern physics. So it's defined as mass times velocity. So its direction is the same as velocity, and its magnitude is mass times velocity. And what Newton's second law translated into equation, it means the net force acting on an object equals to the derivative of the momentum over time. Now, however, I think most of us would be more familiar with the equation that F equals ma as Newton's second law. Now, however, F equals ma is only a special case of Newton's second law if m is constant. If m is constant, then we have F equals ma. If m is not a constant, then we should have chain rule. We should have chain rule of derivative. We should have v times dm dt plus m dv dt, and dv dt of course is a. And if your mass is a constant, then this term is 0. If your mass is not a constant, this term is not 0. So remember, F equals A is a special case of Newton's second law that mass is constant. But fortunately for us in this chapter, that we treat m as a constant almost always. So from Newton's second law, we can find out the unit for force is the same as the unit of mass times acceleration. And we know unit for mass is kilogram, unit for acceleration is meter per second square. So the unit for force is kilogram meter per second square. And we define 1 kilogram meter per second square to be 1 Newton to honor Newton. Now, how do we solve problem involving Newton's second law? It would be extremely similar compared to how we solve Newton's first law problem. That for Newton's first law problem, we have object in equilibrium and acceleration is 0, so net force is 0. And right now, Newton's second law, the object doesn't necessarily have acceleration 0, and actually, if it has acceleration, then the net force equals mass times acceleration. That depends on what kind of acceleration you have. If we do it probably in 2 dimensions, we have our net force in x direction equals mass times acceleration in x direction. Net force in y direction equals mass times acceleration in y direction. So all the ingredients is almost the same as how we solve Newton's first law. So we draw the situation to help us understand, and then we draw free body diagram on the object. Now make sure we only draw all the forces acting on the object, not from the object acting on other objects. And then try to find out each force, label each force using the corresponding letter, and then try to find out how much force we already know its magnitude. And then we build our x and the y coordinate system. And then we find all the components and find the net force in x direction, which give us net force in x direction equals max. Net force in y direction gives us may. And using the equation we built to solve any unknown variable. So if you compare Newton's first law and Newton's second law problem, they are extremely similar until the last step, that you have net force equals 0 for Newton's first law and net force equals m times a for Newton's second law problem. Let's do our first example. Now this time we have an elevator, and this elevator was pulled up by a cable. It's going up with acceleration equals 1.1 meter per second square. We want to find what's the tension at the table. So let's draw our free body diagram. So you have tension pointing up, weight mg pointing down, and there's no force in the x direction. In the x direction, there's no force. And those are all the forces in y direction. So net force in y direction should equals to T subtract mg equals m times a. A is going up, so T equals mg plus ma. And if we put in all the numbers, and we find is 8,066 Newton. So T equals mg plus a. Actually is more general. Let's see if a is 0. If a is 0, then we have T equal mg, which is exactly the example we discussed in this first law, right? So if the elevator is going up, but without any acceleration, then the magnitude of the tension exactly equals to the weight. Now if tension equals 0, we should have mg plus a equals 0, and the a equals negative g, which is negative 9.8 meter per second square, and give us, if there's no tension, the elevator is going to be dropped as free fall with acceleration 9.8 pointing down, which also makes sense. Now example 2. Now we have a ramp, and the ramp has an angle theta with respect to the horizontal direction. We have a mass m just sliding down, and there's no friction. We want to find out in such a case what is the acceleration of the block along the incline. So that's a situation, and we draw free body diagram and the object m. So what are the forces acting on it? We have normal force, we have mg, and then there's no friction at all because it's frictionless ramp. So that's all. We only have two forces acting on it. Now our next job is to decompose all the forces into x and y direction. Now for the normal force, it's pointing in the positive y direction, so we're done. It doesn't have any x component and only pointing in the positive y direction. For the mg, for the weight, we have This is our x, this is our y, and we have proved that this angle is theta. So we know the mg as a vector is angle is 270 degree plus theta. So the x component of mg is mg cosine 270 degree plus theta actually give us mg sine theta, and in the y direction is y component is mg sine 270 degree plus theta, and actually give us negative mg sine theta. So this is x component of mg, this is a y component of mg. Okay, now we're ready to solve it. So, and we can just try to imagine there would be no motion in the y direction at all, right? So there's no motion. The box is going to moving along the ramp, so the motion is in the x direction. Motion in y direction is there's no motion in y direction. So net force in y direction has to be 0, which easily gives us n equals mg cosine theta. Okay. Now, net force in the x direction is not 0 now. So net force in the x direction, only mg has an x component. So the net force in the x direction is simply mg sine theta. Now we find out what's the net force in the x direction. And we also know there is acceleration in x direction if you have a net force. And the net force has to equals max. So ax is net force in x direction divided by mass. Mg sine theta divided by mass give me g sine theta. And this is the acceleration of the box moving down the ramp. Now let's do one more example. Now we have two blocks, one 10 kilogram, one 40 kilogram. They connect by a string. And then there is a 50 Newton force acting on the 40 kilogram block. Question is, what's the magnitude of the tension on the rope? So how do we solve it? If we look at this 10 kilogram and if we know what's the acceleration on it, it's going to be equal to the net force acting on this 10 kilogram, right? And the problem says the surface is frictionless. So in the horizontal direction, the only force acting on this 10 kilogram is T. So MA for 10 kilogram equals T. So if I can find out the acceleration of this 10 kilogram, I can find out what is this tension. The question is, how do we find this acceleration of this 10 kilogram? So what we can do, this is 10 kilogram connecting by a string, 40 kilogram, 50 Newton. What we can do, we can treat these two wood block as one object. Then the net force on it is 50 Newton. Net force equals MA, and net force is 50 Newton. And the sum of those two, 50 kilogram times A. So A is 1 meter per second square. So these two blocks, both of them are moving at 1 meter per second square, going right. So now I draw a free body diagram for the 10 kilogram. The force acting on it is T. Acceleration is 1 meter per second square. So I have T equals M. Let's call it M1. A equals 10 times 1. Newton is 10 Newton. So the magnitude of tension is 10 Newton. And we solved the problem. And that's it for Newton's second law. See you next time.